Welcome. There is nothing to do now but rest. Let your breath slow. Let your shoulders release into whatever is holding you, and let the day dissolve behind you. Tonight we drift outward, world by world, starting close to home. The moon is Earth's only natural satellite. It has kept quiet company with our planet for over 4 billion years, a steady companion turning the night sky into something familiar, something we have always looked up to find. The moon's gravity causes ocean tides on Earth. As it pulls on our planet's waters, the seas rise and fall in a rhythm older than any clock. This tidal breathing-shaped coastlines stirred nutrients through ancient oceans and may have helped early life find its footing between land and sea. Even now, far from any shore, that same pull moves through the water inside every living thing. The moon is slowly drifting away from Earth. Each year, it moves about 4 centimeters farther, carried outward by the same tidal forces it creates. In the deep past, it hung much closer, filling more of the sky and pulling harder on the tides below. In the far future, it will hang smaller, fainter, more distant than it has ever been in human memory. The moon has no atmosphere to weather its surface. Without air or wind, its craters remain almost exactly as they formed, some carved by impacts billions of years old. There is no rain to smooth its mountains, no breeze to shift its dust. Footprints left by visitors decades ago still rest undisturbed in that airless, silent ground. The far side of the moon gets just as much sunlight as the near side. It is not a dark hemisphere, only a hidden one, always turned away from Earth by the moon's locked rotation. Both faces cycle through day and night in equal measure. What differs is simply which half we are allowed to see from home. The moon's surface is covered in fine dust called regolith. Formed by eons of micrometeorite impacts, this powder clings to everything it touches and holds the imprint of every footstep and wheel track. It has no water to bind it, no wind to scatter it. It simply waits, layer upon layer, holding the moon's long memory in gray, fine grains. Water ice exists in permanently shadowed lunar craters. Near the moon's poles, some crater floors never receive sunlight, holding temperatures cold enough to preserve ice for billions of years. This hidden water may have arrived on ancient comets and asteroids. It rests now in eternal shadow, untouched, a quiet reservoir tucked into the coldest corners of our nearest neighbor. The moon likely formed from a giant impact with early Earth. Roughly 4.5 billion years ago, a Mars-sized body is thought to have collided with our young planet, flinging molten debris into orbit. That debris gradually gathered itself into the moon we know today. In a strange way, the moon carries pieces of Earth's earliest self, forever circling the world it came from. Venus is the hottest planet in the solar system. Despite Mercury sitting closer to the Sun, Venus holds the heat record because of its thick blanket of carbon dioxide. Surface temperatures there reach hot enough to melt lead. Beneath its bright, cloud-wrapped exterior lies one of the most punishing environments among all the worlds we know. Venus spins backwards compared to most planets. While Earth and nearly every other planet rotate one direction, Venus turns the opposite way, so slowly that a single rotation takes longer than its journey around the Sun. Astronomers still consider why this happened. Perhaps an ancient collision tipped it over long ago. On Venus, if you could see through the clouds, the Sun would rise in the west. Let the next breath arrive, a little slower than the last, and the one after that slower still. Feel the inhale rise without effort, then let the exhale stretch long, unwinding like a thread let loose. Each breath out can carry a little more of the day away with it. There is no pace to keep, only this, breathing in and letting go, again and again, until the body forgets it was ever anywhere else but here. A day on Venus outlasts its year. The planet spins so slowly that one full rotation takes longer than its entire trip around the Sun. If someone could stand on its surface, a single sunrise to sunset would stretch beyond the length of a Venusian year. Time itself seems to fold strangely there, where the clock of a day runs longer than the calendar of a season. Sulfuric acid forms the clouds that wrap Venus in perpetual haze. These dense yellow-white layers reflect sunlight brightly, which is part of why Venus glows so vividly in our evening sky. Beneath the clouds, the acid never reaches the ground as rain, evaporating long before it falls. The beauty seen from afar hides a chemistry far harsher than any storm on Earth. Beneath those clouds, pressure builds to a force strong enough to crush most machines humans have sent to explore it. Standing on Venus would feel like resting under nearly a kilometer of ocean water. Early landers survived only minutes before the pressure and heat overwhelmed them. It remains one of the most hostile surfaces among all the worlds in our solar system. Viewed from Earth, Venus passes through phases much like our moon. Through a telescope, it can appear as a thin crescent or a fuller glowing disk, depending on its position relative to the Sun. Early astronomers found this observation important, since it helped confirm that planets orbit the Sun rather than the Earth. Venus's shifting light became a quiet piece of evidence in a much larger cosmic understanding. In diameter, Venus comes close to matching Earth, making it something like a twin in size, if nothing else. Its mass and gravity are also similar, near 90% of our own. Yet despite these resemblances, its atmosphere and surface conditions could hardly differ more. Two planets so alike in shape have grown into worlds almost unrecognizable from one another. No moon orbits Venus, leaving its night sky without any companion light. Astronomers have long wondered why, since most planets nearby have at least one. Its slow backward rotation may have made it difficult for any moon to settle into a stable orbit long ago. Venus turns alone through the dark, circling the Sun without a single satellite beside it. Vast plains of solidified lava spread across nearly all of Venus's surface. Countless volcanoes, some larger than any found on Earth, shaped this terrain over billions of years. Much of it appears young in geological terms, suggesting volcanic activity may have reshaped the whole planet not so long ago. Beneath its thick clouds lies a landscape frozen in stone, but born from fire. Carbon dioxide thickens Venus's atmosphere into a trap that never releases heat. Sunlight enters easily, but the warmth it creates has nowhere to escape, building higher and higher over time. This runaway greenhouse effect turned Venus from a possibly temperate world into the hottest planet in our solar system. It stands now as a quiet warning of what unchecked warming can become. Mars holds the largest volcano known in the solar system, a giant called Olympus Mons. It rises nearly 3 times the height of Earth's tallest mountain, spreading wide enough to cover an entire small country. Its gentle slopes formed over ages of slow eruption, undisturbed by the kind of plate movement that limits volcano size on Earth. Standing at its base, the summit would vanish beyond the curve of the Martian horizon. A canyon system called Valles Marineris cuts across the Martian surface like a wound that never healed. Stretched over thousands of kilometers, it would swallow the Grand Canyon many times over. Its walls drop so deep that clouds sometimes gather within them, tiny mist rivers in a stone throat. No flowing water carved this rift, but ancient stretching of the planet's crust. Standing at its edge, one side could vanish into haze before reaching the other. Let your shoulders sink first, heavy against whatever holds you. Feel that weight travel downward, into your arms, into your hands, until your fingers forget they were ever tense. Your hips settle deeper, the mattress rising slightly to meet them. Your legs grow dense, ankles loosening, feet drifting outward on their own. Each part of you is arriving somewhere it can finally rest, and there is nowhere lower left to sink. Two small moons circle Mars, named Phobos and Deimos, each shaped more like a lumpy potato than a sphere. They are thought to be captured asteroids, drawn in long ago by the pull of Martian gravity. Phobos races around Mars so quickly it rises and sets twice within a single Martian day. Deimos moves more gently, drifting so far out that from the surface it looks little brighter than a wandering star. Long ago, liquid water carved channels across the Martian surface, leaving traces still visible today. Dried riverbeds wind through the terrain like memories of motion. Ancient deltas fan outward where rivers once emptied into basins that may have held lakes or even small seas. Orbiting cameras have mapped these shapes in patient detail, tracing a wetter, warmer chapter in the planet's distant past. Dust storms on Mars can grow large enough to wrap the entire planet in a haze of orange particles. Winds lift fine grains high into the thin atmosphere, where they can linger for weeks at a time. Sunlight struggles to reach the surface during these storms, dimming the Martian sky to a dull amber glow. Spacecraft on the ground sometimes wait out these storms in stillness, solar panels dimmed, listening for the wind to finally settle. Iron oxide, the same rust that forms on old metal, gives Mars its familiar reddish hue. Fine particles of this oxidized dust coat nearly everything, from towering cliffs to the smallest pebbles. Winds carry it skyward, tinting even the Martian atmosphere with a faint rosy cast. This rust formed over eons as iron in the rock reacted slowly with whatever oxygen once lingered in the air or water. Among the rocky planets, Mars holds one of the thinnest atmospheres of all. Its air is far too sparse to trap much warmth or shield the surface from radiation. A breath drawn there would find almost nothing to hold on to, the pressure so low that liquid water boils away quickly if exposed. This thin veil is a remnant of a once thicker atmosphere, mostly lost to space over billions of years. Winters on Mars reach depths of cold that dwarf even Earth's frozen poles. Temperatures near the Martian poles can fall far below anything experienced on our own planet's coldest nights. Carbon dioxide itself sometimes freezes directly out of the air, settling as frost or even snow across the ground. In these seasons, the polar caps grow whiter, layered in ice both dry and pale, catching what little sunlight reaches them. Beneath the icy layers near Mars's south pole, radar signals have hinted at pockets that might be liquid water. Salts mixed into this water could lower its freezing point enough to keep it from turning solid, even in such bitter cold. If these hidden lakes exist, they would lie far beneath the ice, shielded from the thin, dry air above. It remains an open question whether they truly hold liquid water or something more ambiguous in form. Phobos drifts closer to Mars with every passing century, pulled inward by the planet's gravity. In tens of millions of years, this small moon may finally come apart, torn by the increasing strain of that pull. Some of its remains could scatter into a faint ring circling Mars, while other fragments might fall gently onto the surface below. For now, it still circles overhead, unaware of the slow ending written into its orbit. Mercury holds almost no atmosphere at all, only a thin trace of scattered atoms too sparse to be called air. There is nothing there to trap warmth once the sun moves away. No blanket of gas cushions the surface. No wind carries heat from one place to another. Whatever warmth the day brings simply escapes back into space once night arrives. Because of that missing atmosphere, Mercury swings between the most extreme temperatures of any planet. Under full sun, its surface can grow hot enough to melt certain metals. Yet within hours, the same ground can plunge to depths of cold rivaling the outer solar system. No other world experiences such a wide gap between its hottest and coldest hours. Somewhere far off, a low hum rises and fades, like a house settling into itself for the night. It comes and goes without hurry, never asking anything of you. Let your shoulders sink a little deeper each time it fades. The sound has nowhere to be either. It simply arrives, rests a moment, and drifts away again, the way your thoughts might now begin to do the same. On Mercury, one day lasts longer than 1 year. The planet circles the Sun quickly, completing an orbit in just under 88 Earth days, but it spins so slowly on its own axis that a single sunrise to sunrise stretches across roughly 176 Earth days. A person standing there would see the year end and begin again before the Sun had even finished crossing the sky. Despite its scorched daytime surface, Mercury hides water ice in craters near its poles. Certain crater floors near the poles never receive direct sunlight, shadowed permanently by their own high walls. Within that endless shade, temperatures stay cold enough to preserve ice for a very long time. Radar studies from Earth first revealed these bright frozen patches tucked into the planet's coldest corners. From a distance, Mercury looks remarkably like the Moon, its surface layered with countless overlapping craters. Billions of years of impacts have left the ground pitted and pale, with almost no wind or water to soften the scars. Long cliffs called scarps wind across its plains, formed as the planet's interior cooled and shrank. The whole landscape feels frozen in an ancient stillness, untouched since its earliest ages. Mercury is small, yet its core takes up an unusually large share of its interior. Iron makes up much of that core, spreading through roughly 85% of the planet's radius. This leaves only a thin, rocky shell wrapped around a metal heart far larger than expected for such a small world. Scientists studying its gravity and magnetic field have found this proportion unlike any other planet in the solar system. Jupiter stands as the largest planet circling our Sun, so vast that all the other planets combined could fit within its volume, with room left over. Its diameter stretches more than 11 times that of Earth. Bands of amber, cream, and rust-colored clouds wrap around it in constant motion. Even from far away, its sheer size makes it unmistakable among the points of light in the night sky. Within Jupiter's swirling clouds churns a storm larger than Earth itself, known as the Great Red Spot. Winds inside this storm can howl far faster than anything recorded on our own planet. It has persisted for centuries, shifting slightly in size and shade, but never fully fading. Astronomers first noted it through telescopes generations ago, and it continues turning, a slow red eye set deep in Jupiter's endless clouds. Jupiter carries the strongest magnetic field of any planet in the solar system. Invisible yet immense, it stretches far beyond the planet itself, shaping a vast region of space around it. This field is powerful enough to trap intense radiation, forming belts that would be hazardous to spacecraft passing too close. Its influence quietly extends outward, weaving an unseen structure through the space surrounding the giant world. Jupiter carries at least 95 known moons, a number that keeps growing as sharper telescopes find smaller companions hidden in its glow. Some are large enough to hold their own icy landscapes, while others are tiny fragments only a few kilometers wide. They circle at every distance, tracing loops both near and far. Around this single planet turns something close to a miniature solar system of its own. Far beyond its swirling clouds, Jupiter's gravity reaches outward like an unseen hand. Comets and asteroids drifting toward the inner solar system often meet that pull first. Many are flung away, captured into new orbits, or drawn into Jupiter itself. Earth has been spared more than a few close encounters, because this giant planet quietly intercepts what might otherwise travel further inward. Jupiter gives off more heat than it receives from the Sun, an odd warmth rising from somewhere deep inside. This heat comes not from any hidden fire, but from the planet's own gradual shrinking, squeezing gravitational energy into glow. Layers of gas compress under their own tremendous weight. The result is a planet that shines faintly with its own inner light, independent of the distant sun. Let the warmth begin at your feet, spreading upward like sunlight, moving through still water. Feel it settle into your ankles, your calves, easing anything that feels tight. Let it rise into your knees, your thighs, unhurried, filling each muscle with heaviness. Allow it to climb through your hips, your stomach, your chest, until your whole body feels held in something warm and unmoving. Rest here a while longer. Hydrogen and helium make up nearly all of Jupiter's atmosphere, the same elements that fill the sun itself. Beneath the visible clouds, hydrogen is squeezed under such pressure that it behaves almost like a metal, conducting electricity through the planet's depths. Streaks of ammonia and other compounds paint the familiar bands of color across the surface. Jupiter, in many ways, resembles a star that never quite gathered enough mass to ignite. Spinning faster than any other planet, Jupiter completes a full turn in under 10 hours. This rapid motion flings its outer layers outward at the equator, giving the planet a noticeably flattened, bulging shape. Seen from a distance, it appears slightly squashed rather than perfectly round. Such speed governs much of the planet's weather, stretching its clouds into the long, streaming bands so often seen in photographs. Io, one of Jupiter's 4 largest moons, glows with more volcanic activity than anywhere else known in the solar system. Hundreds of eruptions dot its surface, some sending plumes of sulfur high above the ground. This restless heat comes from the powerful tidal pull of Jupiter itself, which flexes Io's interior again and again. The result is a moon painted in shades of yellow, orange, and red, forever reshaping itself. Under Europa's icy shell, evidence points toward a vast hidden ocean. Cracks and ridges across its frozen surface suggest movement below, as though something fluid shifts beneath the crust. Sunlight barely reaches this hidden sea, yet warmth from Jupiter's gravity may keep it from freezing solid. Europa remains one of the more compelling places in the solar system to wonder about water existing far from any sun. Water hidden beneath Europa's ice may amount to more than every ocean on Earth combined. Though the moon itself is smaller than our planet, its ocean could run far deeper than anything found here. No sunlight touches this water. No waves break across an open sky. Still, in that dark and pressured deep, planetary scientists imagine conditions might not be entirely unlike the ocean floors we quietly explore on Earth. Ganymede holds the title of largest moon in the solar system, larger even than the planet Mercury. Layers of ice and rock make up its interior, and beneath them, evidence suggests, lies yet another hidden ocean. Its icy surface bears grooves and ridges carved by ancient shifting terrain. Massive enough to be considered a planet on its own, Ganymede simply happens to circle Jupiter instead of the Sun. Ganymede carries a secret unmatched by any other moon, a magnetic field of its own, generated deep within a molten iron core. Auroras ripple near its poles, invisible to the naked eye, but detected by passing spacecraft. No other moon in our solar system produces this kind of field. It suggests a world with real internal motion, not simply frozen rock drifting through the dark. Callisto's face tells a story written entirely in impact scars. Its surface counts among the most heavily cratered in the solar system, largely unchanged for billions of years. Unlike Europa or Ganymede, little internal heat has smoothed or erased these marks. Each crater rests beside another, a quiet record of countless ancient collisions. Amalthea, a small moon tucked close to Jupiter, has a shape that defies simple description. Its lumpy, irregular form suggests a body too small for gravity to pull into a sphere. Strangely, it appears more porous than solid, almost like a loosely packed pile of icy rubble. Astronomers still puzzle over how such a fragile little world survives so near a giant. Jupiter wears rings too, though few people picture them. Unlike Saturn's brilliant bands, Jupiter's rings are faint, thin, and made almost entirely of fine dust. Collisions between small moons and passing debris likely created them. They remain nearly invisible from Earth, revealed only through the careful eyes of passing spacecraft. Somewhere behind your eyes, a low mist has begun to settle. It doesn't rush. It simply fills the room, the way evening fills a valley, corner by corner, without asking permission. Your shoulders loosen beneath it. Your breathing slows to match its unhurried drift. There is only this mist, and the dimming edges of the day dissolving into it. Saturn's rings, glowing pale in any photograph, are built almost entirely from ice. Countless particles, from grains no larger than sand to chunks the size of houses, orbit together in vast bands. Sunlight catches each fragment differently, giving the rings their shimmer. Up close, astronomers say, it would look like flying through a slow, endless snowstorm. Saturn holds an odd distinction among planets. It is the least dense of them all, lighter than water itself. If some vast ocean could contain it, Saturn would simply float. This comes from its composition, mostly hydrogen and helium, gases far lighter than the rock and metal that make up Earth. A giant and yet strangely buoyant. Saturn's rings stretch wider than the distance between Earth and the Moon, yet somehow remain remarkably thin. In places, they measure only about 10 meters from top to bottom. Compared to their staggering width, this makes them thinner, proportionally, than a sheet of paper laid across a football field. Vastness and delicacy existing together. At Saturn's North Pole spins a storm shaped like a perfect hexagon, unlike any weather pattern found on Earth. Each side stretches wider than our entire planet. Winds inside race along its edges, maintaining the six-sided form for decades. No one yet fully understands why the pattern holds together with such geometric precision. Saturn now claims more moons than any other planet, with 146 confirmed and counted. Some are broad icy worlds, others are little more than drifting boulders caught in Saturn's pull. Together they form a quiet, orbiting family, each one tracing its own patient path around the ringed giant. Titan, Saturn's largest moon, holds lakes and rivers unlike anything on Earth. Instead of water, they hold liquid methane and ethane, pooling in cold basins near its poles. Rain falls occasionally from thick orange skies, feeding channels that wind across frozen ground. Robotic probes have mapped shorelines and river deltas remarkably similar in shape to those carved by water on our own world. A familiar landscape, painted in an utterly foreign chemistry. A thick orange atmosphere wraps around Titan, denser even than the air surrounding Earth. Nitrogen dominates it, much as it does here, but hydrocarbon haze gives the sky its amber glow. Surface pressure feels roughly 1.5 times what we experience at sea level. Sunlight rarely breaks through directly. Instead, it diffuses into a low, perpetual dusk that colors every frozen shoreline below. Beneath Titan's frozen crust, researchers suspect an ocean of liquid water may still exist. Tidal flexing from Saturn's gravity keeps the interior warm enough to prevent total freezing. If confirmed, this hidden sea would sit sandwiched between rock below and ice above, sealed away from the orange world overhead. Two oceans, one of water hidden deep, another of hydrocarbons resting on the surface far above it. At Enceladus's south pole, geysers erupt in towering plumes of water vapor and ice crystals. These jets shoot hundreds of kilometers into space, feeding one of Saturn's outer rings with fine icy particles. Spacecraft have flown directly through these plumes, tasting their chemistry from a distance. Salt grains and organic molecules float within the spray, hinting at a rich ocean stirring far below the surface. Enceladus conceals a global ocean beneath a shell of ice that wraps the entire small moon. This hidden sea touches every latitude, kept liquid by heat rising from a rocky core stretched and squeezed by Saturn's pull. Scientists studying its chemistry have found conditions resembling hydrothermal vents on Earth's ocean floor. A tiny moon, barely larger than a city-sized world, harboring an entire sea in the dark. Let the muscles around your eyes soften now, the small unnamed tension behind your brow releasing its grip. Your jaw loosens, lips parting slightly, teeth no longer touching. Behind closed eyelids, there is only a low, shifting dark, loose and unfocused, like the inside of a still shell. Let your face grow unreadable, the way it looks in the deepest hours of night. Nothing to arrange, nothing to hold your features in place, just the weight of stillness settling over your forehead, your cheeks, the space between your eyes. Mimas carries a crater so vast, it gives the small moon an unmistakable resemblance to a certain fictional space station. Named Herschel, this impact scar stretches nearly a third of Mimas's diameter, with walls rising steeply from a deep central floor. Whatever object struck long ago came remarkably close to shattering the moon entirely. Instead, Mimas endured, wearing its old wound like a strange, recognizable emblem across the solar system. Iapetus wears a peculiar ridge running directly along its equator, giving the moon an unusual walnut-shaped profile. This wall of mountains rises many kilometers high, stretching for well over 1,000 kilometers across the icy surface. Its origin remains an open question, perhaps material from a collapsed ring, perhaps forces from deep within the moon itself. Either way, no other body in the solar system wears quite the same shape. Pan, one of Saturn's smallest moons, orbits directly inside a narrow gap within the rings. Its shape resembles a flying saucer, with a wide equatorial ridge formed as it swept up ring material over countless ages. This unusual silhouette makes Pan among the most recognizable of all the small moons photographed by passing spacecraft. A strange little shepherd, sculpted by the very rings it tends. Uranus tips almost completely onto its side, spinning at a tilt of nearly 98 degrees. This means its poles, rather than its equator, sometimes face the sun directly for decades at a time. One explanation points to an ancient collision with another large body early in its own history. Whatever the cause, Uranus rolls through space like a ball knocked askew, carrying its rings and moons tipped sideways with it. Despite Neptune sitting farther from the sun, Uranus holds the record for the coldest temperatures ever measured on a solar system planet. Its cloud tops can plunge below -224 degrees Celsius, colder than any other world we know. One theory suggests Uranus lost much of its internal heat long ago, perhaps during the same event that tipped it onto its side. The planet drifts through the dark, pale, and frozen, holding on to almost none of its ancient warmth. Methane gas, high in Uranus's atmosphere, absorbs red light and reflects blue and green wavelengths back into space. This gives the planet its distinctive pale, almost aquamarine hue, smoother and softer than Neptune's deeper blue. Layers of haze soften the color further, wrapping the planet in a muted, glassy sheen. From a passing spacecraft, Uranus appears less like a storm-racked giant and more like a still, colored marble. Astronomers in 1977 discovered that Uranus carries rings of its own, faint and easily overlooked from Earth. They were found not through direct sight, but by watching a distant star flicker as Uranus passed in front of it, dimming in irregular pulses. Later spacecraft confirmed a delicate system of narrow, dark bands circling the planet. Unlike Saturn's bright, wide rings, Uranus wears its own set almost invisibly, a quiet secret kept for billions of years. Miranda, one of Uranus's smaller moons, hides a canyon named Verona Rupes that plunges far deeper than the Grand Canyon on Earth. Some estimates place its cliffs at nearly 20 kilometers high, among the tallest known in the solar system. The moon's surface looks patchworked, as though pieces of older and newer terrain were stitched together unevenly. Whatever reshaped Miranda long ago left behind a landscape of striking, uneven drama. Because Uranus tips so far onto its side, each pole spends more than 20 years in unbroken daylight, followed by more than 20 years of darkness. A single season there can outlast a person's entire childhood. Sunlight creeps across the planet in slow, sweeping arcs as its 84-year orbit carries it around the Sun. For anyone imagining a year on Uranus, summer and winter would each feel like a lifetime chapter rather than a passing month. Neptune carries the fastest winds ever recorded on any planet, gusting past 2,000 kilometers per hour across its frozen face. These winds tear through an atmosphere lit by only faint, distant sunlight, moving faster than sound on Earth. Dark storm spots drift across its surface, torn apart and reformed by the planet's relentless upper air currents. Even in such cold and dim surroundings, Neptune's atmosphere remains in constant, powerful motion. Let the breath grow longer now, each exhale drawn out a little further than the one before it. There is no need to shape it, no need to count it, only to notice it loosening, softening at the edges. With every slow release, the shoulders sink a fraction deeper into whatever holds them. The next breath comes a little slower still, and the one after that slower yet, like tide easing back from shore. Unlike every other planet found before it, Neptune was discovered not by searching the sky first, but by mathematics. Astronomers Urbain Le Verrier and John Couch Adams independently calculated that an unseen planet's gravity must be tugging at Uranus's orbit. In 1846, a telescope was pointed to the predicted patch of sky, and Neptune appeared almost exactly where the equation said it would. It stands as one of the purest triumphs of prediction meeting discovery. Neptune's deep blue color comes from methane in its atmosphere, which absorbs red light and lets blue wavelengths scatter back toward space. The effect runs deeper than Uranus's paler shade, giving Neptune a rich, saturated hue closer to a midnight ocean. Beneath its visible clouds lie layers of hydrogen, helium, and ice, compressed under enormous pressure. Its color alone hints at an atmosphere thick with quiet, cold intensity. Triton, Neptune's largest moon, moves backward around its planet, opposite to the direction Neptune itself spins. This kind of retrograde orbit is rare among large moons, suggesting Triton was not born alongside Neptune but captured from elsewhere long ago. Slowly, over immense stretches of time, its orbit is spiraling inward, drawn ever closer to the planet it did not originally belong to. One distant era, Triton may be pulled apart entirely, becoming rings of its own. Streaks of dark material trail across Triton's icy surface, evidence of geysers venting nitrogen gas from beneath the crust. Sunlight warms pockets of frozen nitrogen just enough to turn it directly into vapor, which bursts upward and carries dark dust for kilometers. The material then drifts downwind and settles across the ice in long, dark plumes. Voyager 2 caught this activity in 1989, revealing a moon far from inert. One full circuit of the Sun takes Neptune 165 Earth years to complete. Since its discovery in 1846, it has only just finished a single orbit, returning near its original position in the 2020s. A season on Neptune can last longer than 4 decades. Anyone born there, if such a thing were possible, would likely never see a single full year pass. Near Pluto's equator lies a bright, pale region shaped remarkably like a heart, informally named Tombau Regio after the astronomer who discovered Pluto. Nitrogen and carbon monoxide ices form its smooth left lobe, gathering there through slow atmospheric cycles. The New Horizons spacecraft photographed it in 2015, revealing detail no one had ever seen. Against Pluto's dim, distant light, that pale heart still stands out with unexpected clarity. Pluto and its largest moon Charon face each other permanently, locked so that each always shows the same side to the other. Their mutual gravity synchronized both spins long ago, an effect stronger here than almost anywhere else in the solar system. From certain points on Pluto, Charon would hang motionless in the sky, neither rising nor setting. The two worlds turned together like partners in a slow, silent dance. Pluto's thin atmosphere is not permanent. As it swings away from the sun on its long elliptical path, temperatures drop low enough that the atmosphere freezes and falls back to the surface as fresh ice. Later, drawing nearer the sun again, that same ice warms and rises once more into a hazy blue sky. This cycle repeats across Pluto's 248-year orbit, atmosphere appearing and disappearing like slow breath. Among all the rocky bodies orbiting between Mars and Jupiter, Ceres holds more mass than any other, large enough that its own gravity has pulled it into a rounded shape. It was the very first asteroid discovered, spotted in 1801 by Giuseppe Piazzi. Astronomers now classify it as a dwarf planet, distinct from the countless irregular rocks surrounding it. Ceres sits quietly at the center of that scattered belt, like a small world among rubble. Bright patches, scattered across Ceres's dark surface, turned out to be deposits of sodium carbonate and other salts, left behind as briny water rose and evaporated. The Dawn spacecraft mapped these features closely, especially within a crater called Ocator. Beneath the crust, a reservoir of salty liquid may still persist today, slowly cooling. Those pale markings hint that Ceres was, and perhaps remains, less frozen and lifeless than its surface first suggests. Let the weight of the body be noticed now, beginning at the feet. Let them grow heavy, pressed gently into whatever lies beneath them. That heaviness rises slowly upward, filling the calves, settling into the knees, spreading through the thighs like something poured rather than held. The hips sink next, then the lower back, each part releasing its effort one by one. The chest grows heavy, the arms grow heavy, the hands rest as though they have finally set something down. Even the head grows heavy against its pillow, and the whole body becomes something the bed carries, rather than something that carries itself. Far beyond Pluto's orbit drifts Eris, a dwarf planet nearly matching Pluto in mass despite lying much farther from the Sun. Its discovery in 2005 by astronomer Mike Brown and colleagues helped push the debate that eventually redefined what counts as a planet. Sunlight reaching Eris is so weak that its surface stays colder than almost anywhere else measured in the solar system. It circles the Sun on a long, tilted path taking well over 500 years to complete. Haumea spins so quickly, completing a full rotation in under 4 hours, that it has been stretched into an elongated egg-like shape rather than a sphere. This rapid spin likely followed a collision long ago, one that also created its small ring and 2 known moons. Its surface, coated in crystalline ice, reflects light with unusual brightness for something so far from the Sun. Haumea tumbles through the outer darkness, like a stone flattened by speed rather than by time. Makemake, one of the outer dwarf planets, shows no evidence of any atmosphere surrounding it. Its surface reflects sunlight with unusual efficiency, appearing almost as bright as fresh snow despite its distance from the Sun. Discovered in 2005, it orbits far beyond Neptune among the icy bodies of the Kuiper Belt. Without air to soften them, its temperature swings and cratering stay locked in place, a frozen record stretching back billions of years. Beyond Neptune's orbit lies the Kuiper Belt, a vast ring holding thousands of icy bodies left over from the solar system's formation. Pluto and Makemake both call this region home, alongside countless smaller fragments of rock and frost. Objects here drift so far from the Sun that sunlight arrives thin and weak, barely warming their frozen surfaces. This belt marks the edge of the world we still consider close, a threshold before the emptiness widens further. Halfway to the nearest star, Astronomers estimate the Oort cloud may still extend its reach. This vast shell of icy debris surrounds the solar system at distances almost impossible to picture, far beyond anything sunlight meaningfully touches. Comets that fall inward after long journeys often originate here, nudged loose by passing stars or gravity's faint pull. No one yet knows its precise size, only that it dwarfs every world discussed so far. Alpha Centauri holds the title of the nearest star system to our Sun, sitting just over 4 light-years away. It is actually a trio, 2 Sun-like stars locked in a close orbital dance, with a dim red companion trailing farther out. Light leaving those stars tonight would take more than 4 years to reach Earth. Even our fastest spacecraft would need tens of thousands of years to arrive there. Proxima Centauri b orbits the closest star to our Sun, completing a full circuit in just over 11 days. It circles a small red dwarf, tucked in tight where the star's dim light still provides enough warmth. Discovered in 2016, this planet reshaped how astronomers think about worlds near red dwarfs. Its tight orbit means a year there passes faster than most vacations here on Earth. Within its star's habitable zone, Proxima Centauri b receives enough warmth that liquid water could theoretically survive on its surface. Whether it actually holds oceans or any atmosphere at all remains an open question. Red dwarf stars like Proxima flare often, and such outbursts could strip away a thin atmosphere over time. Still, the planet stands as one of the closest possible cousins Earth has ever found. Barnard star hosts a candidate super-Earth, a planet several times heavier than our own circling, one of the fastest moving stars in our sky. This red dwarf lies about 6 light-years from Earth, drifting through space at a pace astronomers have tracked for over a century. The planet, if confirmed, orbits far enough out that it likely stays frozen rather than warm. Its presence still awaits firmer confirmation from future observation. In the Lumen 16 system, 2 brown dwarfs circle each other only about 6.5 light-years from our Sun. These objects sit in a strange middle ground, too massive to be ordinary planets, yet too small to have ignited as true stars. Discovered in 2013, hiding in plain sight for decades, they remind us how much of the nearby sky still holds surprises. Their dim glow comes from leftover heat rather than any starlight. Somewhere beyond the edges of this room, a sound arrives and fades. Maybe wind moving past a window, maybe a house settling into itself for the night. Let it come without meaning, without asking anything of you. It rises for a moment, then eases back into the wider hush that holds it. Your breath can follow that same rhythm, rising, releasing, rising again, needing nothing from you but to keep going. Let every sound tonight simply pass through, unclaimed, while your body rests exactly where it is. TRAPPIST-1 is an ultra-cool dwarf star, dim and small, yet home to 7 known planets orbiting in tight formation. Located about 40 light-years away, it burns at a fraction of our Sun's temperature and brightness. Each planet circles so closely that a year for the innermost world lasts scarcely more than a day. Together, they form one of the most compact planetary systems ever discovered, a small choir of worlds around a modest star. 3 of TRAPPIST-1's 7 planets circle within the star's habitable zone, a region where surface conditions could allow liquid water to persist. That such a small, dim star hosts even one such world would be remarkable. To hold 3 within that gentle band feels like an unusual gift of geometry. Astronomers still study each one, weighing atmosphere and light for any sign of familiar chemistry. These worlds orbit so close together that standing on one, you might see another hanging huge in its sky, larger than our moon ever appears from Earth. Distances between them are small enough that a spacecraft could cross from one to the next in less time than a flight across an ocean. Their skies would show slow-moving companions, shifting phases, shared light. It is a rare kind of neighborhood among planets. Among TRAPPIST-17, the planet astronomers call the fifth, is often named one of the most Earth-like worlds yet found. Its size closely matches our own, and its orbit places it near the balance point where water might remain liquid. No image yet exists of its surface, only inference from starlight passing through its air. Still, of everything catalogued so far, it stands close to the top of that quiet list. This entire system sits only about 40 light-years from Earth, close enough that a future telescope might one day resolve real detail rather than mere shadow and shift. 40 light-years sounds vast, yet among the galaxy's countless stars, it counts as a near neighbor. The light reaching us tonight left those planets not long after some of today's oldest trees had already taken root. Nearness at this scale is its own kind of wonder. Kepler 16b circles not one star but two, both suns rising and setting together across its sky. Astronomers nicknamed it a real-world tattooing after the twin-sunned planet from film. Its orbit traces a wide path around the pair, shaped by their combined gravity rather than any single pull. Watching such a sunset there would mean watching two lights fade in slow sequence rather than one. Kepler 452b carries the nickname Earth's bigger cousin, a planet roughly 60% larger than our own circling a star much like the Sun. It sits within a zone where temperatures might allow liquid water, and its year lasts close to 400 days. No lander has ever reached it, and none likely will soon. Still, among the thousands catalogued, few resemble home quite this closely. Kepler 7b ranks among the least dense planets ever measured. A gas giant so puffed and light that it could almost float on water, if water existed in a container wide enough to hold it. Its bulk rivals Jupiter's, yet its mass is far smaller, leaving it strangely airy for something so vast. Heat from its nearby star likely swells its outer layers into this feather-light state. It drifts more like a cloud than a world. Kepler 10 sits closer to its star than Mercury sits to our Sun, baked into a scorched, rocky surface that may hold pools of molten stone. Daytime temperatures there could melt metal outright. Its year lasts less than a single Earth day, circling so tightly that the star dominates its entire sky. Among rocky worlds discovered so far, few endure heat this extreme. Kepler 90 holds 8 known planets, matching the exact count found in our own solar system. Smaller worlds circle nearer the star, while larger ones drift farther out, echoing a familiar arrangement seen at home. The resemblance seems to hint at shared patterns in how planetary systems take shape. No two of its worlds are identical to ours, yet the architecture feels oddly recognizable. Let warmth begin now at your feet, a low, easeful glow spreading across the skin, unhurried, without effort. Let it climb through your ankles, into your calves, releasing whatever tightness has gathered there through the day. Let it rise into your knees, your thighs, spreading wider as it goes, filling the space behind your hips. Let it reach your stomach, your chest, your shoulders, each part receiving it in turn, softened, loosened, held. Let it settle finally into your neck, your jaw, the small muscles around your eyes, until the whole body rests inside this one long spreading warmth. Kepler 22b earned its place as one of the first confirmed planets found orbiting inside a habitable zone, discovered by the Kepler mission in the year 2011. It circles a star smaller and cooler than our Sun, at a distance that could allow liquid water to persist on a surface no one has yet seen clearly. Its size sits between Earth and Neptune, leaving its true nature an open question. Even so, it marked a turning point in the search for worlds like our own. A star called Kepler 9 hosted the first system found with more than one confirmed planet passing directly across its face. Two gas giants there share nearly matching orbits, tugging at each other's paths as they travel around their star. Astronomers tracked subtle shifts in transit timing to confirm both worlds at once. The discovery proved that transiting planets could reveal entire families, not just single companions. WASP-12b spirals inward, drawn ever closer to the star it orbits, its outer layers gradually stripped away by immense gravity and heat. The planet has taken on an egg-like shape, stretched by tidal forces pulling unevenly across its bulk. Streams of gas trail behind it, forming a dim disk around the star itself. In perhaps 10 million years, astronomers expect the star to finish what it started, drawing the planet entirely into itself. On AD 189, 733b, wind speeds reach several thousand kilometers per hour, fast enough to drive silicate particles sideways through the atmosphere instead of down. Those particles condense into glass, tiny droplets born from the planet's deep blue haze. Telescopes have measured that haze precisely enough to guess at its color from many light years away. The result is a world where rain never falls downward at all, only sideways endlessly. 55 Cancri circles so near its star that its surface likely reaches temperatures capable of melting rock. Beneath that surface, models suggest a carbon-rich interior might crystallize under pressure into structures resembling diamond. No spacecraft has confirmed this directly. The idea rests on measurements of the planet's density and composition. The image persists all the same, a small world glittering with wealth no one will ever touch. Telt 9b burns hotter than many stars, its dayside reaching temperatures near 4,000 degrees Celsius. Orbiting a blue-white star far larger and fiercer than our Sun, this planet is stripped continually by radiation, its atmosphere trailing away like a comet's tail. Molecules there break apart entirely, unable to hold together in such heat. It stands as one of the most extreme worlds known to exist. WASP-76b experiences rain unlike anything on Earth. Iron, vaporized on its blazing day side, drifts to the cooler night side and condenses into liquid metal droplets that fall from the sky. Winds carry the iron vapor around the planet in one continuous cycle. The day side can exceed 2,000 degrees Celsius, hot enough to vaporize metal outright. On the night side, that same iron falls back to the surface as rain. Kepler 70b orbits its star at such a narrow distance that a single year there lasts only a few hours. The planet once likely resembled a gas giant until its outer layers were stripped away by the dying star it now circles. What remains may be a stripped, rocky core surviving impossibly near a stellar remnant. Its whole seasonal cycle, birth to end, would fit inside a single Earth afternoon. Gliese 436b holds ice on its surface despite blistering heat exceeding several hundred degrees Celsius. Immense gravity compresses the planet's water so tightly that it forms a dense, solid state even under such warmth, a form of ice unfamiliar to anything found on Earth. Pressure, not cold, keeps it locked in place. The planet offers a reminder that solid and frozen are not always the same thing. Ogle 2005, Billig 390lb ranks among the coldest worlds ever detected, discovered through a brief gravitational lensing event thousands of light years away. Its surface temperature likely hovers near -220 degrees Celsius, cold enough to freeze nearly every gas into solid form. Astronomers glimpsed it only once, through a passing alignment of light that will not repeat for centuries. It drifts on, distant and dim, in permanent frost. Let your attention settle like dust in still air, drifting down through a shaft of quiet light, in no rush to reach the floor. Each breath moves the dust a little, then lets it fall again. There is nowhere this moment needs to go. Your shoulders can loosen, your jaw can loosen, and the room around you can stay exactly as unremarkable and safe as it is. Let the dust settle, and let yourself settle with it. A pulsar named CIRB 1257+12 gave astronomers their first confirmed exoplanets back in the early 1990s. These worlds circled the crushed, spinning remains of a star that once exploded as a supernova. Radio pulses from the pulsar arrive with tiny, telltale variations, and those variations revealed planets no telescope could yet see directly. It remains striking that the first worlds found beyond our solar system orbit a stellar corpse rather than a living sun. Bourget, a 318.5-22 drifts through space belonging to no star at all. Discovered in 2013, it glows faintly with leftover heat from its own formation, its light unclaimed by any sun to reflect. Astronomers class it among the free-floating worlds, massive enough to resemble a planet, yet untethered from any orbit. It travels the galaxy in a permanent, starless dusk, lit only by its own quiet glow. TF Beadsir 2149-0403 moves through the galaxy bound to no star system whatsoever. Its temperature suggests it should be a planet, yet it wanders free, roughly 100 light-years from Earth. Some worlds like this one may have formed alone in cold, interstellar clouds, never gathering a sun to circle. Others may have been flung loose from a system long ago. Either way, it drifts on in undisturbed solitude. Rogue planets may outnumber the planets bound to stars across the galaxy. Estimates drawn from microlensing surveys suggest that free-floating worlds could be remarkably common, vastly exceeding the number of stars themselves. If true, most planets in the Milky Way answer to no sun, orbiting nothing, warmed by nothing but their own fading interior heat. It is a quiet reminder that belonging to a star may be the exception, not the rule. Rogue planets may hold on to internal heat long enough to allow liquid water somewhere beneath their surface. Without a sun, such a world would rely entirely on heat left from its formation, or perhaps radioactive decay deep within its core. Beneath a frozen crust, a hidden ocean could persist for ages, sealed away from starlight entirely. No telescope has confirmed such an ocean yet, but the physics leaves the door open. JI 1214b is considered one of the more plausible candidates for a true water world. Its low density suggests a composition rich in water, possibly layered beneath a thick steamy atmosphere or compressed into exotic high-pressure ice. The planet lies close enough to its star to stay warm, yet its exact surface conditions remain uncertain. It offers researchers a rare glimpse of what an ocean planet, entirely unlike Earth, might resemble. Kepler 62f is a super-Earth that may be covered almost entirely by ocean. Slightly larger than our planet, it orbits within its star's habitable zone at a distance that could allow liquid water across its whole surface. No mountains or continents may ever break that surface at all. Astronomers picture a single, unbroken planet-wide sea, its only weather written in waves rather than winds over land. TY 1452b is suspected of being another ocean-covered world. Its density suggests a composition too light for pure rock, yet too heavy for pure gas, a signature that fits a planet wrapped in deep water. It orbits a small star, at a distance, allowing moderate temperatures. Researchers studying it hope future telescopes might detect the faint signature of water vapor rising from its surface into a thin, damp sky. 18b shows chemical traces in its atmosphere that intrigue anyone searching for signs of life elsewhere. Observations have detected carbon-bearing molecules and hints of a compound on Earth associated only with living organisms, though the evidence remains far from settled. The planet is larger than Earth, orbiting a red dwarf within a temperate zone. Whether its ocean, if one exists, holds anything alive, is a question no one can yet answer. Ellis 1140b is a dense rocky world wrapped in a thick atmosphere. It orbits a small red dwarf, some 40 light-years away, its mass greater than Earth's, yet its size only slightly larger. Its density suggests an iron-rich core, more compact than our own planet's interior. Astronomers have detected signs of an atmosphere clinging to its surface, thick enough to shape weather we cannot yet name. It remains one of the more promising rocky worlds for closer study in the years ahead. Let the jaw fall loose now, unclenched, unheld. There is a small space just behind closed eyes, dim and unlit, where nothing needs to be seen. The eyelids grow heavier with each breath, settling fully now, without effort. Let the muscles around the eyes release, then the brow, then the temples, one by one going slack. Somewhere behind that darkness, rest is already waiting, unhurried, unmeasured, yours whenever you're ready to receive it. Jai 357d lies near the outer edge of its star's habitable zone. It circles a small, cool star tighter than Earth circles the Sun, yet the star's dim light leaves the planet in a colder, more uncertain zone. Whether liquid water could persist there depends on factors astronomers are still piecing together, from atmosphere thickness to cloud cover. It sits at a kind of threshold, neither clearly warm nor clearly frozen, a planet balanced on a boundary line. Teegarden star B ranks among the most Earth-similar planets ever found in size. Its radius comes remarkably close to our own planets, a rare match discovered orbiting one of the coolest, dimmest stars nearby. It receives a similar amount of energy from its star as Earth receives from the Sun, though the light reaching it would appear a deep, ember-like red. No one yet knows what its surface holds, only that its size alone makes it worth watching. Ross 128b orbits a red dwarf known for staying remarkably steady. Unlike many small stars prone to sudden flares of radiation, this one rarely erupts, sparing its orbiting planet from the harshest bursts. That steadiness matters, since violent stellar outbursts can strip away a planet's atmosphere over time. Ross 128b's star offers something milder instead, a long, even glow that leaves its planet's atmosphere, if it has one, undisturbed. G667cc orbits within the habitable zone of a triple star system. 3 suns share its sky in some configuration, though only one lies close enough to warm the planet meaningfully. The other 2 remain distant companions, faint points of light rather than sources of heat. Astronomers consider this super-Earth one of the more compelling habitable zone candidates, a planet whose warmth comes from just one star among a small crowd of them. Phot 1b circles within a system containing 4 stars altogether. It orbits a pair of stars directly, while a second, more distant pair circles the whole system from far away. Volunteers analyzing data through a citizen science project were the ones who first spotted it, hidden within light curves professional surveys had overlooked. 4 suns light its skies in shifting combinations, a sight no planet in our own solar system will ever show. Kepler 47 hosts multiple planets circling a pair of stars together. 2 suns, one larger and bright, one smaller and dim, orbit each other closely, while at least 3 known planets circle that pair at increasing distances. It stands as one of the few confirmed systems where multiple planets orbit a binary star rather than just one. Sunsets there might arrive twice, in overlapping light, before the sky finally darkens for the night. 55 Concrete E's daytime and nighttime temperatures differ by thousands of degrees. Locked in place by its star's gravity, one side forever faces the star's blistering light, while the other stretches into permanent, frigid dark. The day side may reach temperatures hot enough to melt rock outright, while the night side cools dramatically by comparison. Such an extreme divide turns one small planet into 2 entirely different worlds, joined at a boundary that never moves. Gliese 504b carries a pink hue born from its own glowing heat. Though it orbits far from its star, the planet still radiates heat left over from its formation, faint light-tinted rose by chemistry in its atmosphere. Astronomers detected it directly, an unusual feat for a planet so distant from the glare of its star. Its color offers a rare visible clue to processes usually hidden deep within a planet's interior. Heorot 7b is thought to carry oceans of molten lava across its surface. So close to its star that rock itself liquefies, this small world may have seas that glow rather than reflect. Rain, if it falls at all, could fall as stone through a sky thick with mineral vapor. The planet spins so near its sun that solid ground and liquid ground trade places by temperature alone. WASP 17b travels backward, circling opposite to its star's own spin. Most planets drift in the same direction their star rotates, carried along by the disk they were born from. This one moves against that grain entirely, a puzzle astronomers trace to some ancient gravitational encounter. Its atmosphere has also puffed outward into one of the largest known, a swollen giant tracing a contrary path through its own sky. Let each breath now grow a little longer on its way out than it was coming in. Feel the air enter easily, then leave slowly, unhurried, like a tide pulling back from shore. There is no need to guide it further than this. Each exhale can carry a little more of the day's weight away with it, until breathing itself becomes the only thing left to notice. Hadhad 106906b circles its star at an extraordinarily wide distance. Separated from its sun by hundreds of times the space between Earth and our own star, it drifts at the far edge of what still counts as orbit. Astronomers wonder whether it formed there at all, or was flung outward long ago. Either way, its year stretches across thousands of Earth years, a slow, distant circuit through near emptiness. TRES 2b ranks among the darkest known exoplanets, absorbing almost all the light that reaches it. Less reflective than coal, its clouds swallow starlight instead of scattering it back into space. What little glow it shows comes from its own internal heat rather than reflected light. Seen up close, it would appear as a dim silhouette, a shadow shaped like a planet against its parent star. Kepler 421b holds one of the longest known orbital periods among transiting planets. Its year stretches across roughly 700 Earth days, a slow arc traced far from its star's glare. Detecting it required patience, watching for a single faint dimming that would not repeat again for nearly 2 years. Its distant, deliberate path stands in contrast to the fast, tight orbits so common among known exoplanets. Kepler 1625b may host a candidate exomoon, the first ever proposed beyond our solar system. Astronomers studying its passing shadow noticed a second smaller dip in starlight trailing behind the planet's own. If confirmed, it would mean moons form and survive even around worlds, unlike anything in our neighborhood. The evidence remains debated, a soft signal at the very edge of what current instruments can detect. The OR 8799 system holds 4 giant planets, each one captured directly in images rather than inferred from shadows or wobbles. Spread across wide orbits, they appear in photographs taken years apart, visibly shifting position like a slow-moving diagram come to life. It remains one of the few systems where planets can simply be seen rather than deduced. Their light, faint and orange, comes largely from heat still leaking out from formation. Beta Pictoris b remains young enough to still glow from the heat of its own formation. Born only a few million years ago, and instant by planetary standards, it has not yet cooled into the dimmer, older worlds astronomers usually study. Infrared cameras catch its lingering warmth, even though no visible surface light escapes it. Around it, a wide disk of dust and debris still hints at the raw material such planets are made from. Fomalhaut b's identity as a true planet was long debated because of a dust cloud surrounding it. What early images showed might have been a planet or simply a drifting clump of collision debris catching starlight. Years of careful observation eventually favored the planet interpretation, though uncertainty lingered for over a decade. Its unusual, elongated orbit still raises questions about what kind of history shaped such a strange and stretched-out path. 2MSS J2126 holds one of the widest known orbits ever measured around a star. Its planet drifts so far out that light from its sun takes tens of thousands of years just to cross the gap. Astronomers first wondered if the pair were even bound together at all. Careful tracking of their shared motion through the galaxy eventually confirmed the link, a slow, distant marriage stretched across almost 1 trillion kilometers. Planets have turned up orbiting stars near the crowded center of our galaxy, in the region astronomers call the bulge. There, starlight is thick and gravitational pulls overlap in ways rare farther out. Finding a planet there required watching one star's light bend and brighten as another passed in front of it. The detection method itself borrows light from Einstein's old idea that gravity curves the path of passing photons. Certain exoplanets have been found only through gravitational microlensing, spotted thousands of light-years away, with no other method able to reach them. A foreground star passes directly between Earth and a distant background star, and its gravity briefly magnifies the light like a natural lens. If a planet rides along with that foreground star, its own smaller tug leaves a brief flicker within the flicker. The whole event lasts days, then never repeats. Let the weight of your body settle now, one part after another. Feel your feet grow heavy first, sinking into the mattress like stones set gently down into sand. Let that heaviness climb upward into your calves, your knees, your thighs, each one giving in a little more to the pull of rest. Your hips grow heavy, your back grows heavy, the whole length of you pressing into the bed, as if the bed were rising slightly to meet you. Let your shoulders drop their old weight. Let your arms lie loose and full at your sides, your hands soft and unclenched. Even your head grows heavy against the pillow, heavy and still, as heavy as a world settling into its own orbit and never needing to move again. OGLE 2016-BLG 1928 is a planet with no star at all. It drifts through the galaxy untethered, discovered only because its own gravity briefly bent the light of a much more distant star passing behind it. No orbit binds it, no sunrise ever touches its surface. It simply moves through the dark on a path shaped long ago and never corrected since. Inside globular clusters, where hundreds of thousands of stars crowd into a tight ball, planet formation seems to struggle. Neighboring stars pass too closely, their gravity stirring and scattering the disks of dust and gas that planets need to grow. Searches through several such clusters have turned up far fewer planets than expected elsewhere. It appears that some neighborhoods in the galaxy are simply too busy for young worlds to settle. Across the galaxy, exoplanets appear to outnumber stars themselves. Statistical surveys, built from years of transit and wobble data, suggest that most stars host at least one planet and many host several. Multiply that across the 200 billion stars thought to fill the Milky Way, and the resulting number of worlds becomes almost impossible to hold in the mind. Every point of light in the night sky may be shepherding its own quiet family. Current estimates suggest the Milky Way alone may contain billions of potentially habitable worlds. Not all will resemble Earth, and most will never be visited or even directly seen. Still, the sheer count reshapes how empty the dark between stars actually feels. Somewhere among those billions, conditions might quietly match the gentle balance that allowed life to begin here. On a circumbinary planet, orbiting two stars at once, the sky can offer 2 sunrises and 2 sunsets in a single day. The stars rise separately, drift across the sky at their own paces, and set at different times depending on the season. Sometimes they appear close together, blending their light into one glow. Other times they stand far apart, casting two shadows from every rock and ridge. Certain exoplanets orbit within triple star systems, where three suns share the sky in shifting arrangement. Shadows on such worlds rarely stay simple, sometimes doubling, sometimes nearly vanishing as the stars align. Depending on the season, one sun might dominate the sky, while the other two hang faint and small near the horizon. Days there follow rhythms far stranger than anything our single sun could ever produce. Beyond our own galaxy entirely, the Andromeda Galaxy likely hosts planets of its own, though none have yet been confirmed. Andromeda sits over 2 million light-years away, close enough to see as a faint smudge with the naked eye, far enough that individual planets remain unreachable by any current telescope. Its hundreds of billions of stars almost certainly host worlds by the same logic that fills our own galaxy. For now, those planets remain unseen companions to a galaxy we can only admire from a distance. Astronomers have proposed clever methods for detecting planets in galaxies far beyond our own. Since individual stars in distant galaxies blur together, researchers look instead for tiny dips and flickers in combined starlight, signatures too small to belong to any single sun. Teams working with X-ray telescopes have suggested watching entire star clusters for these subtle interruptions. It is an approach built on patience, searching for a shadow cast by something too small and too far to ever see directly. Extragalactic planet candidates have even been suggested using dips detected in X-ray light, an idea explored by researchers examining X-ray binary systems in other galaxies. When a planet passes in front of such a bright source, the light briefly dims in a way that resembles ordinary transits closer to home. One such candidate was proposed in a galaxy tens of millions of light-years away. Confirming it remains beyond current instruments, but the method itself hints at how far this search might eventually reach. Exomoons, the moons of other planets beyond our solar system, may be common throughout the galaxy, yet they remain extremely difficult to confirm. Detecting a planet already requires precise measurements. Finding a smaller moon orbiting that planet demands even finer instruments. Only a handful of candidate exomoons have ever been proposed, and each remains debated. Somewhere out there, moons may circle alien worlds the way Titan circles Saturn, waiting patiently for technology capable of noticing them. Somewhere nearby, a window is cracked just enough to let in a low hum from outside, steady and unhurried, rising and fading like breath. It could be wind moving through unseen branches, or a house settling into itself for the night, wood and stone finding their old familiar positions. You don't need to name the sound. You only need to let it pass through the room, arriving from somewhere far off, drifting near and slipping away again, taking a little more of your weight with it each time. Certain sub-Neptune exoplanets, smaller than Neptune but larger than Earth, may be wrapped in thick haze that hides their surfaces from view. Telescopes peering through their atmospheres often find only a smooth veil, no clear signs of clouds, rock, or ocean beneath. This haze may form from chemical reactions triggered by starlight striking upper atmospheric layers. Whatever lies beneath remains obscured, tucked behind a soft curtain that light itself cannot fully part. The planet known as Gi 1407b carries a ring system estimated to be roughly 200 times larger than Saturn's own rings. Discovered through a dramatic dimming of its star, the rings stretch so wide that if placed around Saturn, they would nearly reach our moon. Multiple ringlets have been inferred from the pattern of light loss during the eclipse-like event. It stands as one of the most extravagant ring systems ever glimpsed, dwarfing anything within our own solar neighborhood. On certain exoplanets, researchers have theorized skies that rain molten rock rather than water. Extreme heat near some stars can vaporize surface material, which then condenses higher in the atmosphere and falls back down as tiny droplets of stone. Such worlds would glow from their own heat long before any droplet ever touched ground. It is less a storm than a slow return, rock lifted skyward and drawn gently back to where it began. Certain exoplanets orbiting closely bound multiple stars may have skies lit by several suns shining at once. Depending on the arrangement, one sun might sit high overhead while others linger near the horizon, casting overlapping colors across the ground. Shadows in such places could stretch in more than one direction simultaneously, shifting slowly as each star moves along its own path. A sky like that would never truly go dark, only dimmer, waiting for whichever sun rose next. Some brown dwarfs occupy a strange middle ground, too small to have ever ignited as true stars, yet far larger and hotter than any planet. They form the way stars do, from collapsing clouds of gas, but never gather enough mass to sustain full nuclear fusion. Instead, they glow dimly from leftover heat, cooling slowly across billions of years. Astronomers sometimes call them failed stars, though calling them giant planets misses the mark just as much. They simply belong to their own quiet category, neither one thing nor the other. A planet could, in principle, orbit a black hole and remain whole, provided it kept enough distance from the crushing pull near the event horizon. Physicists modeling such systems find the geometry allows stable paths, rings of possibility where gravity bends light but does not shred rock. No such world has ever been observed. The idea stays a thought experiment, a reminder that space bends the rules we take for granted, yet still leaves room for orbits. Deep inside certain planets, pressure alone might turn ordinary carbon into diamond. Models of dense, carbon-rich worlds suggest layers where crystals form under weight no laboratory could recreate, spreading through the mantle like frozen light. Whether any such planet truly exists is still an open question, one built from chemistry rather than direct sight. The thought of a world glittering from the inside out carries its own quiet brilliance. On some distant gas giants, floating life has been proposed as a theoretical possibility, drifting through thick clouds rather than standing on solid ground. Biologists sketching these ideas imagine airborne organisms buoyed by hydrogen-rich atmospheres, catching sunlight or chemical energy as they pass. No evidence supports their existence yet, but the notion widens what life might mean, untethered from any surface, carried instead on wind and pressure alone. The number of Earth-sized planets resting within the galaxy's habitable zones remains uncounted, a figure too vast and too distant to pin down. Surveys suggest the ingredients are common: rocky worlds, warm stars, temperate distances between them. Yet counting each one individually lies beyond current instruments. The uncertainty itself feels less like a gap and more like an invitation, a galaxy still writing its own tally of possible homes. Most stars across the universe, astronomers now believe, carry at least one planet of their own, turning starlight into something less lonely. Overhead tonight, countless such systems turn in the dark, each with its own small arrangement of rock, ice, or gas. We have traveled outward together, from our own moon to worlds beyond naming, and every one of them is real. Let your breath ease, your shoulders loosen, your mind grow heavy as this journey comes to rest. You belong to a universe generous with worlds, and just as generous with rest. Sleep now. Good night.